Next we have a question about integer multiples of 3 and counting number multiples of 2. We have two infinite sets. If we think of all the integer multiples of 3, that's an infinite set. All the counting number multiples of 2 are infinite sets, because we can just keep going forever counting by 3's or counting by 2's. Now there's a little bit more to the idea that we're talking about integer multiples. So now we could use set builder notation to describe this set, but it wouldn't be as detailed as some sort of a listing. So I'm not going to use brackets here. I'm just going to start listing integer multiples of 3. And most people will say, okay, 3, 6, 9, and so forth. Okay? That's not all the integer multiples of 3. Those are the integer multiples of 3 that you're used to, since you use them to determine which problems to do for homework. Okay, but 0 is an integer multiple of 3. Okay, and there are other integer multiples of 3. Can you think of what they might be? You ought to pause and think about this if you don't know. Well, -1 is an integer. If you multiply -1 by 3, you get -3. And a reasonable place to label that would be here. And -2 times 3 is -6. Okay, so we can denote this set using dots as, this continues on this way. We get -12, -15, the negatives of all the numbers we get here. We have to include 0, and then all these numbers. And there is a reasonable representation of the set of integer multiples of 3. Now, counting number multiples of 2. Well, counting numbers start with 1. You don't need 0 to count things. So we count 1, 2. Now, counting numbers start with 1, but that's not a multiple of 2. The first counting number multiple of 2 is 2, and everybody knows that's 2, 4, 6, 8, 10, and so forth. And these are, of course, just the numbers that you use when you're trying to figure out what problems to do. Actually, don't use these, use the multiples of 5. But okay, so how are we going to now, the question is, can we create what's called a one-to-one correspondence of these two sets? A rule that matches every number of each set with some number in the other. Okay, so we want a rule matching every element in each set with some element of the other. Okay, well, that's a little bit of a stumper for most people. And if you can think of one, or if you think you can think of one, you ought to pause and think it through. But I'm going to do something here now. I'm going to use a problem-solving strategy where I use a similar but simpler problem. So similar but simpler. I'm just going to take the sets that you wanted to start with. This one, which is the counting multiples of 3, now that's not what the problem was, but let's see if we can match the counting multiples of 3 up with the counting multiples of 2. Okay, can you see a way to do this? Well, actually, now there is a very easy way to do this. We just indicate that matching with these arrows And now we ask, well, is there a calculation rule? Okay. But there are various ways to get this. Somebody came up with an excellent answer immediately. And I'll tell you what that answer was. But it was totally right. But what we want to do is we want to match the 75th number in this listing with the 75th number in this listing, don't we? Okay? And what would the 75th number here be? Well, it would be 3 times 75, would be 215. And the 75th number down here would be 2 times 75, or 150. So 215 would match 150. Now that's great if we want to find the 75th number. But now if I give you a number in this set, like let's say 39,630, okay? Now 39,630 in this set, okay, let's go 39,630, let's go 39,633. So let's see. This is the number I said, but let's take this one. I don't remember exactly what digits I used. There's a simple strategy to my using that number, and I know that that number is a multiple of 3. Okay, it's 3 times 12,131. But I was sure that that was going to be a multiple of 3. Okay? And the way I did that, there's a more subtle rule. If it's got all 3's in the digits, it's a multiple of 3, it turns out. What number goes with this one? And what number down here would we use? Well, I just divided this by 3, but I get 12,131. So, let's see. 36,393 is 12,131. I'll say it's number 12,131 as the first set. Okay, because if I divide this by 3, I find out what its position is within the set. And then down here, okay, well, to get the 12,131st number, the second set, we multiply that by 2. And that's 24,262. So now, this number goes here. And I've calculated the number that goes with this one, and this gives you a strategy. Divide the number here by 3, and then multiply that by 2. Or if you got a number down here that you want, you divide it by 2 and multiply by 3. So, our rule is divide by 3 and multiply by 2 if we're trying to figure out what number here goes with up here, or divide by 2, multiply by 3. Now there are other ways to do it. Somebody immediately just came out with, well, you know, the number down here is 2/3 of the number up here. Somebody just came up with that right in class. That was very good. It showed excellent understanding, showed that they probably worked through this whole thing and saw that each of these numbers is maybe they just saw each of these numbers as 2/3 of this and didn't go through this process. If the multiples are like 51 and 87 or something like that, then it wouldn't be as obvious how these go. Or if these numbers were offset a little bit, you wouldn't have the same fraction. And that's going to become a problem up here if you try to come up with a rule for this one. But that is perfectly valid rule. Or you take, let me go a different number. I'm not going to write this out. You're going to take 2/3 or 3/2, depending on which set you want to match up with which. Now, that works fine here. What are you going to do up here? We'll address that next.